We're going to be looking at tree diagrams. With tree diagrams, we're going to be focusing on two different events, event 1 and event 2. Event 1's coming first, and then event 2. With the events, there's different possibilities. So we have branches for each possibility. So normally it's like A and not A, but let's say there's an A, B, and C. So one would be A, one would be B, and one would be C. So what we're doing is we're putting branches for each of the possibilities, and then based off of the branches, we have branches off of those. So we have a very technical explanation here, but in the most part, what we're going to do is we're going to look at the example, and then based off of the example, we're going to be figuring it out. So in this case, what we have is two different marbles. We have green marbles and we have red marbles. So we have two branches. We have green and we have red. And so the probability of getting a green marble would be 3 out of 10 because 3 plus 7 is 10. So the probability of picking a red marble would be 7 out of 10. Now, if we have a green marble in our hand, there's two possibilities. Either we have a green or a red. And if we have a red, we either have a green or a red. Now, given we have a green marble in our hand, the probability of getting another green marble would be 2 out of 9 because we have one green marble in our hand. So there's no longer 3, it's now 2. No longer 10 marbles, there's 9. The red marbles would stay the same, still 7, but there's only 9 in there. Now, if we have a red marble in our hand, the probability of picking a green would be 3 out of 9. And the probability of picking a red, since we would have one less red, would be 6 out of 9. One thing that you notice when we're looking at these is that the branches add up to 1. The branches add up to 1, and the branches add up to 1. So for our first one, we're finding the probability of picking two red marbles. That means it's going to be a red, and then it's going to be red again. So that would be 7/10 times 6/9, which would be 42 over 90. The probability of picking one red and one green. This is kind of a tricky one because when we're picking one red and one green, it doesn't tell us the order. So technically, it could be green, red, or it could be red and then green. So it would be 3/10 and 7/9, or it could be 7/10 and 3/9. And that would give us 42 over 90. Now, letter D, the probability of picking at least one green marble. At least one green marble could mean that it could be green red, or it could be red green, or it could be green green. So I'm going to start off with the green green, and that would be 3/10 and 2/9, or it could be the green red, which is 3/10 and 7/9, or it could be the red and green, which is 7/10 and 3/9. And that, of course, would be 48 over 90. Now, for another example, what we have is Grant and Evan, and they enjoy playing Legos, and there's an 80% chance that they are playing Legos. If they are playing Legos, there's a 10% chance that they'll fight. If they do not play Legos, there's a 30% chance that they'll fight. So we start off with our first event, and that would be Legos or not Legos. I'm going to put the little C there. That means complement or not Legos. Probability playing Legos is 0.8. So that means not Legos is 0.2 because those branches have to add up to 1. If they're playing Legos, there's two options. They're going to fight or they're not going to fight. Probability that they fight would be 10%. That means not fight would be 90%. If they're not playing Legos, it could be fighting or not fighting. And not playing Legos and fighting would be 0.3, and then this would be 0.7. So what's the probability that they fight? Now, if they fight, we're trying to figure how do you get to F? Well, that would be Legos and fighting, or it could be not Legos. and fighting. And so when we calculate that, what we have is 0.08 and 0.06, which of course gives us 0.04. 0.14. Now, what is the probability that they will fight if they are playing Legos? So given, we know that they're playing Legos. So if they're playing Legos, what's the probability that they fight? And that would just be the 0.1. And then what is the probability that they will play Legos if they are fighting? Now, this one's a little bit more complicated. So the given part is the second event. It's not the first event like the last one where it was easy to figure it out. The given part is that they are fighting. Now, we know that the probability of them fighting is 0.8 and 0.1 plus 0.2 and 0.3. Now, of those two events, those are the two fighting events, which is the one where they are playing Legos? And the one that they're playing Legos, we put on the top. And so what that gives us is 0.08 over 0.14, which of course is 8 over 14. Some people like to put just the decimal, 0.571. You can either put the fraction or the decimal. Do not put the decimal fraction. That would be incorrect.